In this video, we're going to go over the Unit 1 quiz review problem and how to answer all of them. So on this first one, we have this function of 3x minus e to the x minus 2 minus 4 from the domain of negative 5 is less than or equal to x is less than or equal to 5. So for part A, to find the x-intercepts, IB wants you to graph this. So what we're going to do is in y1, we're going to type in our function, and y2 we're going to type in 0, because if you think about it, the x-axis is at the value of y equals 0, and we're going to see where they cross. So we're going to press second trace and then number 5, or you can go down 4 times to the intersect option. Then when both graphs appear, you're going to move your blinker to the first x-intercept and press enter 3 times. At the bottom, it will give you your x-intercept point. You should have x equals some value, and then y will equal 0. And then we're going to repeat the steps again for the second x-intercept. So again, you don't have to retype the function. So we'd start with second trace and then press 5, or go down to intersection and press enter. This time you need to move your blinker to the second x-intercept and then press enter 3 times to get that point. And our 2 points are 1.54, 0 and 4.13, 0. And again, don't forget, it needs to be 3 sig figs, or you need to write the whole entire value out. So then sketching it, the first thing with IB is you have that restricted domain. So on this grid, even though in the x it goes from -3 to 7, you want to make sure you have the same domain that they give you. But when you graph it, press window and make your window scaling match what they have, so you know exactly what you need to draw. The first thing, I'm going to plot in our x-intercepts and y-intercept just to give me some idea of points to go through, and then literally, since it says sketch, I'm just sketching a graph that looks like the one I graphed on my graphing calculator. Now, you do need to have the similar shape, and it needs to look like you drew one line. And again, you don't go past -1 in the left direction. You don't go past 5 in the right direction. And that would be our function. So our next one is a composition and inverse. So for A, we want to find the composition g of f of -2. So our first step is we need to plug -2 in for f, because f is that inner function. So we have -2 to the third minus 4. -2 to the third is -8. So -8 minus 4 is -12. So -12 becomes our next input value, and so we're going to input -12 into g and find our final value. So 2 times -12 is -24. So the composition g of f of x of -2 is equal to -24. So then to find the inverse, we're going to swap where f of x and x are, or again, I like to write it as y instead of f of x when I'm doing inverse. So x equals y to the third minus 4. And now we just want to get y back by itself. So we're going to add 4 to both sides, and then we need to take the cubed root, because we have y to the third equals x plus 4. So to get y by itself, we have to get rid of that cubing function. So the cubed root is what we do. So our inverse is the cubed root of x plus 4. So in this one, we are given the standard form of a quadratic equation, and it wants us to find the c and d value in our vertex form. And if we look, c is inside the parentheses with x, d is added on at the end. So c comma d is the vertex. So in our original function, we can find the vertex by finding the axis of symmetry. So x equals -b over 2a. So negative times -12 divided by 2 times 2 gives us positive 12 divided by 4. So x equals 3. So that's going to be the x value of our vertex. The y value we will find by plugging 3 into our original function in standard form. So 2 times 3 to squared minus 12 times 3 plus 23. Calculate that out, and we get f of 3 equal to 5. So 5 will be the y value of our vertex, or in this case, C and D. So our equation for part A is y equals 2, parentheses x minus 3, close parentheses, squared, plus 5. For part D, it wants us to find the values of k, p, and q. And it says that we have a vertical stretch with scale factor k. So vertical stretches, that value is the value in front of your parentheses in vertex form. So k is going to be 2. P is a horizontal translation. That translation is inside the parentheses, and this one is 3. Remember, inside the parentheses, you use the opposite value. And then Q is a vertical translation, so Q will be 5. Alrighty, we're given a quadratic function where our a, b, and c terms have some variable k, and we need to determine the values of k for which our function has no real roots. So no real roots means 1, you're not crossing the x-axis, but 2, the discriminant, so the part of the quadratic formula inside the square root is less than 0. So in this case, that would be b squared minus 4ac is less than 0. So we need to identify those. So a equals k, b equals negative k minus 3. So if you simplify that and distribute the negative on the outside, it's negative k plus 3. And then c equals k minus 8. Now on our variable expression for b, that negative on the outside, if you ignore that, you end up with the same result because, again, we are squaring everything, so a negative square will go away. By everything I meant we're squaring b because it's in the formula. So now plugging it into the formula, we have negative k plus 3 squared minus 4k times k minus 8. So our first expression we need to FOIL. Our second we need to distribute. So when we FOIL, we have k squared minus 6k plus 9. When we distribute the negative 4k to k minus 8, we have negative 4k plus 32. Combine like terms, we have negative 3k squared plus 26k plus 9 is less than 0. So now we can factor the left-hand side. So the first thing I'm going to do is I'm going to factor out a negative 1 and keep it on the outside. And then I'm going to factor, so how I like to factor is through bottoms up. Factor by grouping will also work. So by bottoms up, what we want to do is we want to get our expression where a is a value of 1. So we're going to take 3 to the back by multiplying it back to your c value. So when you do that, we now have k squared minus 26k minus 27. And now we can factor by finding two terms that multiply to negative 27 and add to negative 26. That would be negative 27 and a positive 1. But we have to bring that initial 3 back into the situation. So since we multiplied it to the back, we need to now divide our back values by 3. Our first one simplifies, we have k minus 9. Our second one doesn't, so we bring that bottom, in this case 3, up to the front of that factor. And we get 3k plus 1. Now here's the thing. We have that negative 1 sticking outside our two expressions. So we need to distribute that to either the first term or the second term, but it means we could have two possible answers where we distribute the negative 1 to our first factor and have negative k plus 9 is less than 0, and then we have 3k plus 1 is less than 0. Or we can distribute that negative 1 to our second factor, and we have k minus 9 is less than 0, and negative 3k minus 1 is less than 0. So either of these could be answers, so we're going to look at both of them to see if both of them always work. So on the first one, we have that k is greater than 9 when we solve that inequality, and our second one would be k is less than -3. So on a number line, we would have open circles at our two k values, and they are going in opposite directions, so there's a gap between the middle. On the second one, we have k is less than 9, and k is greater than -1/3. So on this one, you have it where it is connected in the middle. Now for this problem, only one answer works. Our blue or our bottom one cannot work, and our green or our top one is the only correct answer. So our answer for this problem is k is greater than 9 and k is less than -1/3. And here's the reason. If we go back to the quadratic formula, we have -b plus or minus the square root of b squared minus 4ac all over 2a. So remember, in our top equation, our a value is k, which means k cannot be 0. If you look at our number line on our blue function, 0 falls between -1/3 and 9, which means that 0 could be within that range, and we know we can't divide by 0, so k can't be 0. So since k is within that range on that given problem, it does not work, so only the top one works in this situation. Alrighty, our final question. We have a rational function. The first thing we want to do is find our inverse. So again, inverse means swap your x and y values. So we have x equals 3y minus 4 divided by y plus 2. And we want to get y back by itself. So the first thing we need to do is we need to get rid of the denominator. So we're going to multiply y plus 2 to both sides. And we have 6 times y plus 2 equals 3y minus 4. So distributing that x, we have xy plus 2 equals 3y minus 4. So again, our goal is to get y by itself. So since we have multiple y terms, anytime you have something where you have more than one y term, you want to get all of your y terms on one side and then everything else to the other side. So we're going to subtract xy to the other side and have 2y minus 3y minus 3y minus xy minus 4. And then because 4 doesn't have any y's with it, we're going to add that to the other side. So now we have 2x plus 4 equals 3y minus xy. So on the right-hand side, since both terms have y, we can factor out a y, and we have 2x plus 4 equals y parentheses 3 minus x. So then our final step to get y by itself is to divide by 3 minus x. So our inverse will be 2x plus 4 divided by 3 minus x. For part B, we want to find the domain. So the domain of any rational function is all real numbers except for the value that makes the denominator 0. So in this case, it is all real numbers except x cannot equal 3. And again, how we got that is your denominator can't be 0. So set it equal to 0, 3 minus x equals 0, so x equals 3. That is the only value that cannot be within your domain.